Hello, AP Statistics students. Mr. McNichols and I wanted to send out today's video. Before we start, though, we want to remind you your exam is Friday, May 22nd at 2 p.m. You must sign in at 1:30. That will go through security protocols and put you in a waiting room. Our top resources, as always, is Schoology. We have our material on there, getting ready for the exam information, and the AP Statistics exam info, which Mr. McNichols went over in the last video. This video is going to cover Chapter 2. We're going to go over some hints, tips, reminders, and resources. For Chapter 2, however, there were tons of concepts. There were percentiles. There was cumulative relative frequency graphs, z-scores, finding them and interpreting them. There were linear transformations. There was the empirical rule, 68, 95, 99.7. There was normal distributions calculations using Table A and using normal CDF. There was even assessing normality. There were so many concepts in Chapter 2. They're all important to keep in mind. This video is only going to focus on z-score and normal distribution calculations. So what we have here is a previous AP exam question. A professional sports team evaluates potential players for a certain position based on two main characteristics, speed and strength. Part B says strength is measured by the amount of weight lifted, with more weight indicating more desirable, greater strength. From previous strength data for all players in this position, the amount of weight lifted has a mean of 310 pounds and a standard deviation of 25 pounds, as shown in the table below. Bam, there it is. Calculate and interpret the z-score for a player in this position who can lift a weight of 370 pounds. The z-score for a player who can lift a weight of 370 pounds is z equals statistic minus parameter over standard deviation. So 370 minus 310 over 25, which is 2.4. That is the value of the z-score. The z-score indicates that the amount of weight the player can lift is 2.4 standard deviations above the mean. Notice it gives a direction for all previous players in this position. You are asked to calculate and interpret the z-score. One thing that's really important to see here, and you see it in the big bold title on top, but you haven't heard me say it yet, is that the z-score does not necessarily mean percentile. When you read this prompt, you are told nothing about the shape of the distribution. We cannot go to Table A on this. We cannot use normal CDF, but you can find z-scores. Z-scores are not only used for shapes that are approximately normal. Z-scores are used to tell how many standard deviations away a value is from the mean. So what we did is, this is the answer. Here's how it's graded. EPI. A couple of things we wanted to point out is the ones that are in the big gray bullet points. Calculating a probability from a normal distribution for the weights is considered extraneous and not a sufficient interpretation of a z-score on it. Luckily, they're considering going to a normality extraneous, and they're not marking it incorrect because they never indicate a normality. Students who do that are getting pretty lucky on this rubric. Never assume normality. Your job is to either be given it or you can justify it, as we have learned throughout the year. Percentiles are extraneous and cannot be used to indicate direction from the mean because the distribution cannot be determined from the information. You don't know the shape of the distribution. Either the formula with the correct symbols or the correct numerical values is needed in addition to the value 2.4 on it. So you either have to use the symbols or you have to use the numerical values. In other words, you have to show work. You can't just give 2.4 as the answer on it. The other bullet points, you can read them for it. We're not going to really talk about them on this. But the bottom line is, we were shocked by some of the grading on this, but don't think this is the standard rubric. Some of these big gray bullet points shocked Mr. McNichols and I on this. Wow, we would have given them a P or we would have given them an I on that. And the students got lucky. That doesn't mean you're always going to get lucky. So here is an example of an essentially correct problem. They went through, they filed everything completely. They have the formula, they have the numbers plugged in, either or, it doesn't matter which one worked, it was fine. And they have this good interpretation. I mean, look at it. They found the z-score, they stated it, and they went and they interpreted it. Pretty clear and precise. This student kind of did one mistake on it right away, is they used the wrong formula. They used X bar. They did not use X on this case. They treated it like a sampling distribution when it was not. However, down here, they do have 370 minus 310 divided by 25. They have the right numerical values, so they got lucky. They did not get marked off for this. They even drew a normal distribution curve, which is wrong. They cannot do that. They cannot assess normality because they weren't told it was normal. So when we go through, they though said the z-score for a player is 2.4. What this student forgot to do is this student did not interpret the z-score. So they were marked down to a P. Well, now, Mr. Nichols, as I were talking about this, says they should have been marked down in our classroom. We would mark them down to an I because there were a couple mistakes on there. But this student got lucky in this case. They got marked down to a P because they did not interpret the z-score on it. That was part of the question for it. And then you have here, you have a going through this part. This person was lucky. They got essentially correct. They got the right z-score. They even have the right interpretation. However, they did the same thing. They decided to use a z-score and go into table A or go into normal CDF and get a percentile. You weren't told normality. They were lucky this extra stuff did not hurt them in this time. It could hurt them in the future on it. So the idea behind it all is answer the question you're being asked, not the question you think you're being asked. Nowhere in this prompt does it say it is a normal distribution, and it does not give you the ability to see if it's normal or to prove if it's normal or approximately normal. More is not always better. You could say something incorrect and lose points by trying to brag statistically through it. Answer the question and move on. Be thorough but concise. And that's why this person right here in the beginning, not a lot of writing. They were right thorough. They were right there concise. They knew exactly what they were doing. And be ready to interpret everything. Be ready to interpret z-score. Be ready to interpret r squared. Be ready to interpret what a standard deviation is. Be ready to interpret everything, which is why our resources for this video is interpretations. We have templates and examples for many AP statistics concepts on it. And if you look at the 2011 exam, look at question 1, that one goes through a lot of stuff that this video went through. So if I pull those up right now, is we have here the interpretations. It goes through by chapter for you on all the different things outlined. We also have the AP exam. If we go down to 2011 and you click on the free response questions, you could look at question 1. You can even look at scoring commentary for it as well on it. So that is our video today. Over 5 minutes, but you know what? 2.5 extra minutes with me is great for it. I hope you guys are all doing well. Please stop in office hours and ask questions.